طيب يعطيكم العافية. هلا إن شاء الله راح نكمل بمادة الفارماسيتيكال أورجانيك كيمستري. هاي المحاضرة السادسة. راح نحكي عن توبيك جديد اللي هم الإيثرز والإيبوكسايدز. طيب إذا حكينا وخلصنا موضوع الألكوهول فينولز، وراح نحكي اليوم عن فانكشنال جروبز جديدة اللي هم الإيثرز والإيبوكسايد. راح نحكي عن الإيثرز والإيبوكسايد، عن النيمينج، عن physicochemical properties، وراح نحكي as well عن some reactions, how to prepare ethers and epoxide, and how do these functional groups react with other functional groups, وكيف نعمل تفاعلاتهم. أول شيء راح أحكي عنه اللي هو naming of ether. كيف بنسمي الإيثرز؟ There is two ways اللي هم common and opaque systems as we all know. And to know the naming or to learn the naming to learn the name for those functional groups اللي هم الإيثرز, we gonna watch a video for this. A very simple video shows the difference between IUPAC and common names. Please go ahead and watch the video now.
In this video, we're going to focus on naming ethers. We're going to talk about the common names and also the IUPAC names. So let's start with this example. Let's say if we have CH3, O, CH2, CH3. What is the common name of this particular ether? So notice that we have a methyl group on the left, and on the right, we have an ethyl group. If you recall, methane is associated with 1 carbon, ethane is for 2 carbons, propane is for 3, butane is 4, pentane is 5, hexane is 6, heptane is 7, octane is 8, nonane is 9, decane is 10. So we have 2 carbons on the right, so it's an ethyl group, 1 on the left, methyl. And to put it together, we need to alphabetize it, so it's called ethyl, methyl, ether. This is the common name. Now what about the IUPAC name? What is it for this particular example? Well, let's redraw it. So the longest structure, or the longest chain, is the 2 carbons on the left. So I'm going to write it like that. And then I'm going to draw this as a substituent. So we have an OCH3 group. So notice that on carbon 1, we have this group, which is called a methoxy group, as a substituent. So it's 1-methoxyethane, or simply methoxyethane. The ethane is the parent chain of the 2 carbons on the left. So this is the IUPAC name for this particular ether. Let's try another example. Let's name this particular ether. Feel free to pause the video and work on this example. On the right, we have 2 carbons. On the left, we have 4 carbons. So we have a butyl group on the left and an ethyl group on the right. So it's already in alphabetical order. So it's called butyl ethyl ether. Now that's the common name. But what about the IUPAC name? So let's redraw it. So here's the longest chain. It's 4 carbons. And the substituent is this portion of the molecule. OCH3 is known as methoxy as a substituent because it has only a methyl group. Here we have an ethyl group attached to it. So this is called ethoxy. So it's 1-ethoxy, and the parent name is butane. It's a 4-carbon alkane. So 1-ethoxy butane. That's the IUPAC name for that example. Now how about this example? How can we name this particular ether? So notice that we have an ethyl group on both sides. So we have 2 ethyl groups. It's not called ethyl-ethyl ether, but it's simply diethyl ether. So that's the common name. Now for the IUPAC name, we're going to treat one side as a substituent. So I'm going to write it as OCH2CH3. So once again, this is ethoxy, and it's on carbon 1. But if it was here, this would be carbon 1. So for a 2-carbon chain, no matter where you put the ethoxy group, it's going to be on carbon 1. So you could just call it ethoxy ethane. And that's all you got to do for this one. Here's another one that we could try. What's the common name for this particular ether? Now, on the right, we have an ethyl group. On the left, we have 3 carbons, but based on the way it's connected, this is an isopropyl group. So E comes before I. So this is ethyl, isopropyl, ether. Now what about the IUPAC name? What is it for this particular molecule? So I'm going to redraw it. First, I'm going to draw these 3 carbons because that's the longest chain. So 2, 3. And on carbon 2, I'm going to draw the ethoxy group. So I'm going to rewrite it like this. So you can clearly see that the ethoxy group is on carbon 2. So it's 2-ethoxy, and for a 3-carbon alkane, it's propane. So 2-ethoxy propane. That's the IUPAC name for this ether. Now what about this one? Let's focus only on the IUPAC name. What is the IUPAC name for this structure? So first, we need to identify the longest chain. Should we count it from right to left or left to right? If we count it from left to right, we're going to have 2 substituents at 3 and 4. We have an ethoxy group at 3 and a methyl at 4. If we count it from right to left, the methyl is going to be on carbon 2 instead of carbon 4. So you want to count in the direction that's going to give you the lower numbers. So we want to count that way. So now we got to alphabetize it. Which one comes first, ethoxy or methyl? E comes before M, so we're going to put the ethoxy group first. So it's 3-ethoxy dash 2-methyl, and for a 5-carbon chain, it's pentane. So this is the answer. Now, what about this one? Let's say if we have not only an ether, but also an alcohol group. And also a halide. How can we name this particular compound? So which group has more priority, the alcohol or the ether? Alcohols typically have more priority than ethers. So to name it, we're going to give the OH the lower number. So we're going to count it from right to left. Now we have a bromo group on 4 and a methoxy group on 3. So Br is going to be written first because it has the lower alphabet. So it's 4-bromo dash 3 dash methoxy instead of ethoxy because the ether has a methyl group. And then dash 2, we have a 5-carbon chain, so instead of saying pentane, it's going to be pentanol. The OH is on carbon 2. So that's it, 4-bromo, 3-methoxy, 2-pentanol. Now what about this example? How can we name this particular ether? Let's start with the common name. So on the right, we have a methyl group. On the left, we have a cyclopentyl group because it has a ring with 5 carbons. And C comes before M, So it's going to be called cyclopentyl methyl ether. Now what about the IUPAC name? Well, first we need to identify the longest chain, and it's clearly the 5-carbon ring. So that's going to be called cyclopentane, and this is the substituent, which is known as methoxy. So it's simply called methoxy cyclopentane. Well, that is not cyclopentane. I forgot the Y. Here it is. Try this one. Let's say if we have a 6-carbon ring and an OCH2 CH3 group. So let's start with the common name. On the right we have an ethyl. On the left we have a cyclohexyl group. So C comes before E in the alphabet, so it's cyclohexyl ethyl ether. Now for the IUPAC name, the 6-carbon ring is the longest chain, so that's going to be called cyclohexane. And the substituent is ethoxy, and it's automatically on carbon 1, so we could just write it as ethoxy cyclohexane. Now what if you have a molecule that looks like this? How would you name it? So we have 2 ethers. So I'm going to redraw it. So what is the IUPAC name for this compound? So this is a substituent, that's methoxy. We have another methoxy group. One of them is on carbon 1, the other is on carbon 2. Now the longest chain is the 2-carbon chain in the middle, which is ethane. And since we have 2 methoxy groups, we're going to call it dimethoxy. So it's 1,2-dimethoxy ethane. Now let's try one last example similar to this one. How would you name this ether? So this is a ethoxy group, and here we have another ethoxy group. Now we want to count it from left to right, not right to left, so we can get the lower numbers. So we want to make this 1, 2, 3, 4, 5, 6, 7, 8, 9. The longest chain is 9, which is nonane. We have a ethoxy group at 1 and 6. So it's going to be 1,6 dash diethoxy nonane. And that's it. So now you know how to name ethers.
Alright, so after watching the video now you should be able to name any type of ethers. And as you have learned from the previous slide, the ethers have 2 different naming systems زي the other functional groups and the common names. And the common names, what we do is we identify the 2 organic substituents اللي موجودين على الأكسجين and add the word ether. So it's, for example, as we can see over here, we have the isopropyl. So this is an isopropyl methyl ether because we have an isopropyl here and you have this methyl, so it's called isopropyl methyl ether. طبعا ال I بتيجي قبل M لأنه it's by alphabetical order. And then we have this compound by common naming. You have this ethyl as a 1 substituent, you have this phenyl as a 2nd substituent, so this is called as ethyl phenyl ether. And in that case, when you have 2 methoxy groups على الphenyl ring, we call them para-dimethoxybenzene. Why did we say para? Because one of them is para to the other one. And the last one we have over here, this is basically, if we want to name it, it's the IUPAC naming for this compound, 4-tertiary butoxy 1-cyclohexene. So we chose the longest hydrocarbon chain, and this is the 6 member cyclic ring اللي هو cyclohexane. This is the longest hydrocarbon chain. So this is a cyclohexene. طبعا والدبل bond has a higher priority than الether. الالkene أو ال compound with a double bond has higher priority. So they get to be numbered first. So we start with this 1 2 3 4. We can do the other way 1 2 3 4 5 بس راح يطلع هنا 5 substituent. So you choose the one with the lower number. So we do 1 2 3 4 and for number 4 we have tertiary butoxy, 4 tertiary butoxy, 1 cyclohexene. Okay, for each of those compounds بدي تعرف الIUPAC naming as well as the common name. إذا عندك فيهم أي مشكلة, as we all know, we try to tell me what's the problem with any of those compounds or the naming of those compounds, and we can try to fix them as well. طيب هلا نحكي شوي عن ال physical properties of ethers. Ethers, as you all know, oxygen there is an sp3 hybridized carbon, which means that this carbon is a tetrahedral, or this of one oxygen is a tetrahedral atom. So the bond angle in ethers are tetrahedral bond angle. طبعا ال tetrahedral bond angle, as we all know, somewhere between 108 to even 112. يعني لو حكيت لي 109 زي ما حكيت لك 109 ونص 110, I am fine with that. And so they're just tetrahedral in shape. They have a pyramid shape as well, and then all of these sp3 hybridized atoms, the carbons, oxygen, have the same tetrahedral shape. The oxygen as well in the ethers give a slight dipole moment. وحكينا سابقا عن الethers وقارنتهم بالالكحول. And if we drew an ether over here, this is just a simple ether carbon. بغض النظر شو في other things attached to those two carbons. We all know that the oxygen is more electronegative than carbon, so that oxygen has a partial negative, بينما الكربونز اللي هون two carbons have partial positive. And so that give a slight dipole moment. And what we mean by slight dipole moment إنه في زي في قطب موجب وقطب سالب. الموجب اللي هو هدول الكربونز over here. These two carbons have positive, and this oxygen has a negative charge. Okay. And so this is important for the physical-chemical properties of the ethers, وجود الدipole moment. Also, as we all know, لما حكينا عن الالكحول versus ethers, we know if we have only ether molecules, لو كان عندنا فقط ethers, the boiling point تبعين الether molecules together are much lower than alcohols. وحكينا شو السبب إنه ethers with each other, the molecules of ether with each others alone, they can't make hydrogen bonding, so their dipole interaction is very weak. And as we said here, in a slight dipole moment, so their dipole interaction is very weak, which means that they can just do slight interaction, small interaction, weak interaction, compared to alcohol, which can do a hydrogen bonds between each other. إذا كان عندنا methanol, two methanol molecules, they can do hydrogen bonding, so that makes the alcohol boiling point much higher than ethers. So the ethers have a boiling point very comparable للهكسين والهبتين والأوكتين. So وجود الأكسجين ما بيضيف كثير على boiling point تبعتهم. And compared to alcohol, their boiling point are much lower than alcohols, as we have discussed earlier. طيب, one more thing عن الethers, they are miscible in water, which means بيذوبوا بالماء. إلهم دائبية. سبب الدائبية فعليا إنهم الأكسجين, the oxygen molecule that we have over here, is basically can do hydrogen bonding مع OH molecule or H2O molecule. فلو رسمنا H2O molecule over here, we can make simply a hydrogen bond between the hydrogen over here. This is a hydrogen bond. Let me draw it right in a better way. Okay, so this is a hydrogen bond between this hydrogen over here and this oxygen. So between hydrogen and this oxygen we have hydrogen bond, which make the solubility of ether very good in water. This oxygen that موجود بهاي الether makes those ethers solubility is very good in water. هلا طبعا you have to understand إنه if you have a longer hydrocarbon chain too, or if you have long hydrocarbon chain attached to this carbon, لو ضفنا كثير carbons هون, if we want, let me draw this in a better way. So if we compare the solubility of dimethyl ether. Draw it down here. If you draw the solubility of this compound, dimethyl ether, versus the solubility مثلا of dipropyl ether. Which one is more soluble in water? Definitely the one with the lower number of carbons is the one that's more soluble in water. لأنه الكربونز اللي بنضيفها على structure, these are non-polar atoms that reduce the solubility in water. So dimethyl ether is more soluble than dipropyl ether if we want to compare their water solubility. Okay. Alright, so these are just the main physicochemical properties اللي لازم تعرفهم عن هدول structures. And we need to know just three things. sp3 hybridized, which means they have tetrahedral bond angle. We have a slight dipole moment, and we have a low boiling point compared to alcohol. حكينا عن هذا سابقا. وآخر شيء miscibility in water. They are miscible in water because they can make hydrogen bond with water molecules. طيب خلينا هلا إذا نطلع على تفاعلات هدول compounds. How do they react, and how can we prepare an ether, and how ether can be prepared from other functional. أول شيء رح نحكي عنه اللي هو Williamson ether synthesis, and this is simply a reaction of alkoxide with primary alkyl halide. وحكينا عنه سابقا هذا الرياكشن, بس ما حكينا اسمه اللي هو Williamson. Williamson is the name of the scientist that discovered this reaction, and basically this reaction happens like this, very simple. حكينا في عنا alcohol, we can add to it a base, either sodium hydride, sodium hydroxide, whatever base, or a metal if you want, and we can convert that alcohol to alkoxide. So this is the alkoxide produced from that reaction. هلا الالكوكسايد بنروح بنفعله مع alkyl halide زي الميثيل bromide, methyl iodide, methyl chloride, or any other type of alkyl halide, and that can react الالكوكسايد عليها الأكسجين عليها negative charge, as you can see. So it's a nucleophilic atom, and what it can do, basically it can do nucleophilic attack, as you can see over here in this arrow. The arrow goes from negative to positive to attack this carbon. الكربون اللي هي attached to the halide has a partial positive, as we all know, والiodide has a partial negative. لو بدنا نرسم الcharges اللي عليهم. Okay, so the negatively charged oxygen attacks over here. Let me use the pointer. Attacks to a nucleophilic attack على هاي الكربون. If we make a new bond with this oxygen with the carbon هون راح نكسر bond بدالها, فبتطلع الأيودين, which is a good leaving group, as we all know. كل الهالايدز considered as a good leaving group, and so we can make this compound where the oxygen bonded to this methyl. Now هاي الأكسجين بما إنه عليها two alkyl groups, عليها methyl وعليها cyclopentyl, this compound is an ether that's named as cyclopentyl methyl ether. So this is one of the simplest way to prepare ether, and this is the most common way to prepare ether. إن هو نجيب alkoxide مع alkyl halide نفعلهم together راح يعطونا ether. It's named as Williamson ether synthesis. مش مهم كثير النيم, بس مهم يعني تعرف إنه تفاعل alkoxide مع alkyl halide, which is this over here, alkoxide مع alkyl halide, to give us the ether compound. It's a very easy and very common reaction. طيب الطريقة الثانية لتحضير الإيثرز وهي less common methods. هلا راح أحكي عن two more methods بهذا السلايد والسلايد الجاي عن تحضير الإيثرز. They are much less common than the previous Williamson ether synthesis. Williamson ether synthesis method is the most useful, the most common method. الطريقة الثانية هي طريقة أخرى مستخدمة أكثر بتحويل السugars to alcohols. And as you all know, sugars have, or sugar molecules زي glucose, galactose, sucrose, all of those sugar molecules have hydroxyls. You can see all of these hydroxyls over here. These hydroxyls are free hydroxyls that can be alkylated. ممكن نضيف عليهم alkyl group عشان نحولهم لإيثر. How can we do this? Typically, this is done with the help of silver oxide. بوجود السيلفر oxide نقدر نحضر نحول الالكحول اللي موجودين بالsugars to ethers. So the reaction of alcohols with silver oxide with the presence of alkyl halide can give you an ether in one step, and this is very common method عشان نحضر ether from the sugars. So in this reaction we will see that the glucose reacts with excess iodomethane. لما نحكي excess معناته we're using many equivalents. يعني for each molecule of glucose we're using 5 equivalents or more even of alkyl halides اللي هو موجود هون اللي هو الميثيل ايودايد. So كلمة excess معناته انه مش واحد لواحد الريشيو اللي مستخدمينها. مستخدمين for each molecule of that compound مستخدمين a lot more from the other reagent. So for we're reacting glucose with iodomethane وزي ما حكينا excess iodomethane in the presence of silver oxide to generate pentaether. Pentaether يعني في 5 ether molecules 5 ether functional group بنفس المولكيول. Let's see the reaction over here. So glucose has multiple free hydroxy groups that are reacted with the iodomethane. So ضفنا عليه iodomethane. طبعا هذا التفاعل ما راح يتم لحاله هيك، بيحتاج ل some type of catalyst. Catalyst will make the reaction easier to happen, and that's silver oxide. Silver oxide راح يفاعل iodomethane and this is your alkyl halide مع الالكوهول اللي موجودين بالsugar glucose to be able to prepare اللي هو الpentaether molecule this is your pentaether molecule. And so you can see all of the alcohols now are ethers because we added a methyl group to these compounds, and this is becoming an ether functional group بدل ما تكون الكحول. وراح يطلع من التفاعل اللي هو الايودايد اللي هو راح يطلع منه silver iodide. silver iodide اللي هو الايودو اللي كانت هون just react with silver وطلعت outside. Okay, so again reaction is basically between alcohols الموجودين بالglucose plus a methyl iodide or any type of alkyl halide. مش شرط methyl iodide، ممكن نستخدم methyl bromide. We can use ethyl bromide, we can use ethyl iodide, we can use propyl iodide and do the same reaction. In that reaction we have methyl iodide with alcohol presence of silver oxide. الميثيل راح يضيف على ال OHs وراح تطلع الاي مع السيلفر، فراح ينتج عنا باي برودكت سيلفر ايودايد وراح ينتج عنا البنتاميثيل ايثر كومباوند. اوكي، so this is the second method. First method اللي هي ويليامسون ايثر، second method اللي هي السيلفر اوكسايد ميثود. الثيرد ميثود اللي هي الالكوكسيميركوريشن اوف الكين. ولما تسمع كلمة alkoxymercuration of alkene, now you should remember that we have previously discussed this method when لما حكينا كيف بنعمل hydration of alkene، كيف بنحول alkene to alcohol. حكينا one of the common methods is to use alkoxymercuration اللي هي بنستخدم mercuric acetate or mercuric trifluoroacetate بوجود الووتر. كنا نستخدم هناك عشان نحضر الكحول. هنا بدل ووتر راح نستخدم methanol or ethanol, any type of alcohol. Okay, so that's an oxymercuration step, or بدل ما هي oxymercuration كنا نسميها بحالة الهيدريشن of alkene سابقا، هلا بنسميها alkoxymercuration. why it's an alkoxy؟ هناك كنا نحكي عنها oxymercuration. oxy بس بنضيف اكسجين اللي هي water molecule على alkene عشان نحضر الكحول. هلا بطل اسمها oxymercuration، صار اسمها alkoxymercuration. اوكي، شو صار اسمها alkoxy؟ ليش؟ لانه بنضيف alkoxy جروب. alkoxy اللي هي RO. this is an alkoxy وطبعا بيكون عليها negative charge، ما بيهمني charge. اوكي، so it's an alkoxymercuration of alkene. so instead of addition of water molecule سابقا عشان نعطينا alcohol، هون راح نضيف alkoxy group to prepare our ether molecule. اوكي، طيب خلينا نشوف كيف هذا الرياكشن بيتم. عندنا هون example اللي هو styrene. styrene is just an alkene molecule. وين الالكين structure الموجودة؟ over here we can all see this alkene moiety أو double bond structure. if we react this with اللي هو mercury trifluoroacetate or mercury acetate نفس الشيء، ما بتفرق بكانك تستخدم mercury trifluoroacetate or mercuric acetate. يعني ممكن تستخدم هذا أو تستخدم اللي هو هذا المولكيول موجود سابقا وحكينا عنه بالoxymercuration of alkene. so you can use بدل F تستبدل ال F اللي هنا بهيدروجين. ما بيهمني يعني نقطة بس للتوضيح. اوكي، طيب هلا we can use إذن mercuric acetate or mercuric trifluoroacetate. this is the molecule mercuric trifluoroacetate وهذا اسمه mercuric acetate. okay, we can use either or in presence of alcohol, and this is your alcohol over here. so in that case we're using methanol. الميثانول هو اللي راح يعمل اديشن على الدبل بوند. اوكي، راح يعمل اديشن على الدبل بوند. طيب اذا بتتذكروا من الاوكسيميركوريشن رياكشن اوف الكينز اللي حضرنا منهم الكحول، وين راح تضيف الووتر موليكيول لما كنا نستخدم اوكسيميركوريشن؟ كنا نحكي على more substituted carbon, and in those two carbons راح امسح هون الارو. in those two carbons of alkene عندنا كربون هاي وعندنا هاي الكربون، خلينا نسميهم this is carbon number 1 and this is carbon number 2. which one is more substituted? you have to look at this. الكربون 1 فعليا ما عليها الا 2 هيدروجينز، هذول مش substituent. السبستيتيوت اللي هم الالكيل جروب اللي بنحكي عنهم. الكربون اللي هون number 2 as we can see, let me use the laser pointer. So carbon number 1 only has 2 hydrogens، ما في عليها alkyl substituent، فما في عليها أي substituent بنحكي. الكربون الثاني هون عليها hydrogen and 1 phenyl group, so it has 1 substituent. So if the methanol will add، بدها تضيف على هاي البوند، وين راح تضيف؟ راح تضيف على المور substituted، لأنه احنا مستخدمين ميركوري أسيتيت. وحكينا بالميركوري أسيتيت والميركوري ترايفلورو أسيتيت، هاي الميثود adds your H2O سابقا لما حكينا عن الأوكسيميركوريشن، بتضيفها على المور substituted carbon. هون لما نحكي عن الألكوكسيميركوريشن the same rule applies. Your alkoxy group or your methanol or your alcohol group adds on the more substituted, which is over here on this carbon. So this is the intermediate you get from this reaction. Intermediate you get from this reaction that your alcohol will add over here. This alcohol going to add over here on this carbon of the double bond. That's the carbon over here, carbon number 2. Okay. بالميركوري راح نضيف over here على list substitute carbon، ما بيهمنا هذا الحكي. فراح ينتج عندنا هون البرودكت over here. This is the intermediate عفوا مش البرودكت. شوف هي الانترميديت. You're also CH3 or the alcohol group ضافت على هاي الكربون اللي حكينا اللي هي المور substituted، وبضل اخر شيء الميركوري بتروح على الكربون اللي substituted. To get rid of that mercury we use، عشان نحول هاي الميركوري اللي موجودة على الكربون الثاني اللي to hydrogen، بنستخدم صوديوم بوروهيدرايد. بيجي H- بيطلع هذه الميركوري out and it adds over here to that carbon. So that's very simple reaction. And بدي تفهم ال end product of that reaction. ما بيهمني ال intermediate كثير، بس تفهم ال end product تبعه اللي هو if I have an alkene. راح امسح اللي كتبته هون over here briefly just to add things to clear things up. So if you use a mercury acetate or mercury trifluoroacetate مع الكحول، الالكحول راح يضيف عندي على المور substituted carbon، وبالاخير بنستخدم صوديوم بوروهيدرايد to remove our mercury molecule and produce our final product, which is we can see in that final product over here. I'm going to use laser pointer. So in that final product, that methanol عفوا added to the more substituted carbon، بينما ال less substituted اجى عليها الهيدروجين فقط. اوكي، اللي اجى الميركوري بعدين بدلناه بهيدروجين. So اذا انا سالتك بالامتحان او باذر places في ميركوري اسيتيت مع ميثانول، بتحكي لي الميثانول بتضيف على الكربون، وبعدين الميركوري اسيتيت راح تضيف على الليس سبستيتيوتد، وبنضيف عليها الصوديوم بوروهيدرايد عشان نشيلها. هلا يمكن انا في نقطه بسيطه ما شرحتها سابقا، انه in general لما نحكي الاديشن اوف اور سبستيتيوت او الامبورتنت جروب بهي الحاله اللي هي الميثانول صارت على المور سبستيتيوتد كربون، we call this as Markovnikov addition. Markovnikov اللي هو اسم الساينتست اللي discovered this، انه الاديشن of your substituent راح يكون على المور substituted carbon. So this is called as Markovnikov rule. والماركوفنيكوف هو الساينتست درس هاي الشغله وعرف انه دائما لما نعمل هذا الرياكشن بوجود الميركوري دائما راح يصير السبستيتيوانت تبعك او الجروب اللي راح تضيف جديد اللي هي الالكول راح تضيف على المور سبستيتيوتد كربون. So بنسميها ماركوفنيكوف addition. Okay. Alright. So this is the second the third method for preparation of ether. So the first method اللي تعلمناها for preparation of ether is what? First method is Williamson ether synthesis, just alkoxide مع alkyl halide. الميثود الثانية اللي هي حكينا عنها silver oxide. silver oxide مع الكحول راح يضيف بوجود alkyl halide، راح يضيف الalkyl halide على الكحول ويعطينا ether زي ما شفنا بحالة الشوجرز، وبستخدم كثير للشوجرز. واخر ميثود اللي هي الالكوكسيميركوريشن، زيها زي الاوكسيميركوريشن بس بدل بدل ووتر موليكيول ما كنا نستخدم بالالكين، هلا بنستخدم الكحول جروب. اوكي. طبعا بالاضافه للميركوري اسيتيت بدنا نضيف اخر شيء اللي هو صوديوم بورهيدرايد عشان يشيل لنا الميركوري اوفر هير ويعطينا اور ether. That ether is named as 1-methoxy 1-phenyl ethane, and this is the IUPAC name for that molecule. اوكي. طيب هيك بنكون خلصنا تفاعلات تحضير ال ايثرز اللي هم 3 تفاعلات اللي كلنا تعلمناهم. خلينا نشوف كيف الايثرز ممكن يتفاعلوا. How do ethers react؟ كيف انا بشوف تفاعلات، كيف باخذ ايثر وبقدر احوله ل other functional groups. And the first one that you should think about is that you should know about that ethers are generally unreactive. كثير صعب انا اروح افاعل ايثر واكسر الايثر او احولها ل other functional group. This is almost impossible, very very hard to do. And so it's not impossible, but it's very very hard to do. So this is kind of very rare reactions. هدول الرياكشنز اللي هنحكي عنهم. They're not typically done. طيب the first reaction اللي بدي احكي عنه من تفاعلات الايثر انه هو احطم الايثر لالكوهول بلس الكيل هيلايد. احطم الايثر لالكوهول بلس الكيل هيلايد. هو فعليا الريفيرس of the previous reaction اللي هو الويليامسون ايثر سينثيسيس. لما حكينا عن ويليامسون ايثر سينثيسيس حكينا هو تفاعل الكيل هيلايد مع الكحول. الكحول راح نحوله الكوكسايد، يعني بوجود بيس فعليا نقدر نحكي الكحول مع الكيل هيلايد راح يعطينا ايثر. هلا بقدر ارجع الايثر back to the alcohol and alkyl halide. So it's kind of reverse reaction for the synthesis of ethers. And this is usually done under strong acidic conditions. Strong acidic conditions of when you add them, or strong acid when you add them to ether, they cleave the ether. راح يحطموا الايثر at high temperature. شو acids بقدر استخدمهم؟ I can use hydrogen iodide or hydrogen bromide to produce an alkyl halide. And that خلينا to skip هاي النقطة. less hindered component by SN2. هلا راح نحكي عنها. بس خلينا نشوف simply كيف الرياكشن بيصير. If we want to look at this اللي هو الإيثيل فينيل إيثر. الإيثيل فينيل إيثر can be reacted with hydrogen bromide بوجود ريفلكس اللي هو high heat. الهيدروجين برومايد هاي راح تيجي تعمل رياكشن مع الإيثر وتحطمه لفينول and bromoethane. راح يتحطم to phenol and bromoethane. And this is a very simple reaction. البرومين اللي هون اجت مع الايثين اللي هون، والفينول الاكسجين طلعت مع الفينيل رينج عشان تحضر لنا الفينول. So this is a kind of reaction to destroy, to cleave your ether and back to the alcohol and الالكيل هيلايد. So what did we do؟ أضفنا HBr لإيثر، أعطانا الكحول plus الكيل هيلايد اللي هو برومو ايثين. طيب كيف بصير التفاعل؟ بريفلي راح اكتب الميكانيزم اوف ذات رياكشن. طيب اذا خلينا نشوف الميكانيزم لاول تفاعل. بيسكلي عندنا هون الاكسجين تبعت الايثر. راح امسح هذا الحكي اللي موجود بس خلينا to present things here. And then we have HBr هون which is a strong acid. طيب ال HBr is a strong acid that dissociate يعني to H plus and Br minus. يعني راح يتحطم to H plus and Br minus. H plus can go and protonate that oxygen over here. So the lone pair of electrons بيروح بياخذوا ال H هون وبيعطونا protonated oxygen. شو البرودكت اللي راح ينتج؟ راح امسح هون هذا اللي كتبته over here to make things easier. And we're gonna write the product. هلا الاكسجين صار عليها positive charge لانه صار عليها بروتون. طيب اذا ال H plus تبعت ال HBr راحت على الاكسجين وعملت لها protonation. طيب شو ضل عندنا منها؟ ضل عندنا منها اللي هي ال Br minus. So we only have the Br minus that's left over here. Let me draw it in a better way. So we have Br minus. So عليها negative charge ال Br. ال Br راح تروح تعمل nucleophilic attack. وين بدها تعمل nucleophilic attack؟ عندنا هاي الكربون that's directly attached to oxygen is basically let me point at that carbon over here. This carbon عليها راح يكون partial positive. Okay, so it will have a partial positive charge, and so that carbon have a partial positive and can be a target for nucleophilic attack by negatively charged bromine. So let's delete that partial positive عشان نكتب الارو صح. هلا النيجاتيفلي تشارج برومين النيجاتيف تشارج راح تعمل اتاك هون على هاي الكربون، راح تكون رابطة جديدة مع هاي الكربون, and in exchange of that you break this bond, the electrons of that bond goes back to the oxygen. Let me draw the arrow in a better way. Okay, so the bond's electrons over here goes back to oxygen, والاتاك تبعت البرومين راح تصير على هاي الكربون، راح ينتج عندنا two products اللي هو البرومو ايثين. now the bromine over here اللي شفناها راح تصير attached على هاي الكربون او راح ترتبط على هاي الكربون، والاكسجين راح تطلع مع الفينول ring. So what we did, we broke or we cleaved our ether اللي هو الايثيل فينيل ether. طلعت الفينيل as phenol وطلعت الايثيل as bromo ethane. واضحة؟ So you have two products produced from that. This is a cleavage reaction. Cleavage يعني break of your structure into two moieties or two parts. Okay? So this is simply the mechanism. Again, I'm going to repeat briefly the mechanism. اللي هو oxygen over here. I'm using the laser pointer. So the oxygen over here will be protonated first لأنه ال HBr is a strong acid فبتعطي proton تبعها for this oxygen. It's much stronger than oxygen. Oxygen is very weak. لو كانت OH very weak acid, بس هو ال HBr راح تعطي البروتون تبعها أول شيء للأكسجين يصير له protonation. This will make this carbon very strong partial positive. راح تكون عرضة للأتاك or nucleophilic attack by Br minus on the carbon, and then the electron lone pairs or electrons الموجودين بالرابط راح يرجعوا للأكسجين to make your phenol, and then you have a bromoethane. So this is simply the mechanism. طيب هلا so as you know the mechanism now راح امسح الميكانيزم وراح نسأل السؤال التالي. طيب لو كان عندي structure, and let me delete all what I've done over here. لو كان عندنا structure في عندنا two alkyl groups attached to it. We have this ethyl and then we have isopropyl. So two groups attached to it. إذا أنا رحت فعلت هذا الإيثر مع hydrogen iodide. It's a strong acid زي hydrogen bromide. These are acid halides بنسميهم كلهم. هلا أول step زي ما كلنا بنعرف راح يصير في عنا formation of this product اللي هو protonation of oxygen as we have seen previously. So what we're gonna see over here is basically that the oxygen will take this proton over from that HI وراح يصير عليها protonation. So it will be protonated to OH plus زي الفيرست ستيب اللي شفناها سابقا. طيب هلا بهاي الحالة عندنا two options. The attack of the I minus اللي ظلت موجودة can be either on this carbon over here that's a part of the ethyl group أو الكربون اللي موجودة على الisopropyl. Which one would the attack will happen? Okay, that's very important to know. And we need to know the attack, the I minus can attack this carbon اللي عليها partial positive أو هاي الكربون الثاني اللي هي جزء من الايزوبروبيل. يعني هل راح تعمل attack على الإيثيل ولا راح تعمل attack على الايزوبروبيل؟ إذا تعملت attack على الإيثيل راح يطلع عنا iodo-ethane product. إذا عملت attack على الايزوبروبيل راح تطلع عنا البرودكت اللي هو isopropyl or isopropyl iodine. Okay, so which one would be attacked? Simply we can see here that the attack happens at the carbon that's less hindered. شو يعني less hindered؟ الكربون اللي أقل عليها groups، الكربون اللي easily accessible، اللي ما عليها كثير groups بتعمل عليها hindrance، steric hindrance، ما بتعمل عليها bulkiness بتمنع الاتاك. So the attack always in SN2, and this is an SN2 reaction, not an SN1 reaction. The iodine or iodide group over here اللي طلعت من ال HI going to attack over on the position of the carbon over here, which is this carbon of the ethyl. ليش الإيثيل؟ لأنه بس عليها one methyl group جنبها. بينما الكربون هون it's a secondary carbon فعليا عليها two alkyl groups attached to it. So it's more sterically hindered. So it's going to attack الأيودين على less hindered، يعني على one that has only one alkyl group اللي هي a less hindered carbon, and so it will bind to that carbon. So the iodine going to bind to that carbon over here, and that makes this product. The product that we get is the iodoethane. اللي راح يطلع هو الايودوethane. So iodide will attack على الكربون that's less hindered, and you will get the iodoethane, وراح تطلع الالكترونات الاكسجين ترجع إلها، راح تضل مرتبطة على الايزوبروبيل group, so you will get an isopropyl alcohol plus iodoethane. الother product if you want to think about it اللي هو لو صارت الاتاك على الايزوبروبيل، طبعا هذا الحكي ما راح يصير لان المور hindered carbon راح يكون عندنا اللي هو زي ما حكينا isopropyl iodide plus ethanol. هذا الحكي ما راح يصير، بس انا بحكي imagine if this happened. Okay, so the product that we get is an iodoethane plus isopropyl alcohol, لانه الاتاك of the iodine will happen from the less sterically hindered side. Okay, it's very important to know this and to understand this as well. طيب هيك بنكون حكينا عن تفاعلات الإيثر. هم بس فقط تفاعل واحد اللي هو cleavage of ether أو destroying the ether to two molecules. وهم فعليا مش reactive زي ما حكينا، فما في كثير تفاعلات نعرفهم أو ما في كثير أشياء نعرفها عنه. هلا بدنا نحكي عن sub group of ether أو جروب فرعية من الإيثر الأصلية اللي بنسميهم الcyclic ethers. In general, cyclic ethers behave like acyclic ethers, زيهم زي linear ether اللي كنا نشوفهم سابقا, except one, which is the three-member ring. وراح نكتب هلا عن three-member ring بالnext slide ونشرح عن these three-member rings that are called epoxides. So epoxides are three-member ring cyclic ether. This is the main structure of epoxides. Okay, so these are epoxides ring. Cyclic ether, في عنا two carbons are attached in this cyclic ether and one is oxygen. Okay, all right, so these are epoxides. Epoxides behave differently than all of those cyclic ethers العاديين اللي راح نشوفهم. الcyclic ethers زي four member ring، يعني الرينج اللي بتكون cyclic ethers 4 atoms أو 5 atoms زي 5 member ring 6 member ring. All of these behave similarly linear ether او الاcyclic ether اللي بنسميهم acyclic ether، زي مثلا الميثيل ايثيل ايثر او الدايميثيل ايثر اللي شفناهم سابقا. الوحيد اللي بيختلف عنهم الخصائص الفيزيكو-كيميكال بروبرتيز بتختلف عنهم تماما، اللي هم 3 member ring cyclic ether اللي بنسميهم as epoxides. So if we want to look at these compounds, let's look at the naming of these compounds. هلا simply they have usually مش راح اسالك عن الIUPAC names for those cyclic ethers، بيهمني بس تعرف الcommon name. For example, this compound which has خلينا نطلع هذا on the one on the right side over here, this compound is known as tetrahydrofuran. tetrahydrofuran هو عبارة عن حلقة خماسية في 4 كربونات وواحد من الممبرز أو من الحلقة الخماسية راح يكون أكسجين. This is called as tetrahydrofuran. If you want to know what furan is this is a furan ring. ليش بنسميه tetrahydrofuran؟ لأنه هاي الفيورين فعليا عليه 2 double bonds. This compound is called as furan. Okay, so furan has 2 double bonds as you can see over here. Okay, and in the tetrahydrofuran هذول ال 2 double bonds صار عليهم reduction. شو يعني صار عليهم reduction؟ عشان نعملهم reduction راح نضيف عليهم 2 H2s، يعني 4 hydrogen atoms راح نضيف عليهم 2 H2s عشان نحولوا ل tetrahydrofurans. So furan is basically a compound that was reduced to tetrahydrofuran by addition of total of 4 hydrogens. That's why we call it a tetrahydrofuran compound. This compound has also a specific known common name. ما راح احكيه، بدي اتركه for you or for the students to know what's the common name of that compound. It's a 6-member ring instead of 5-member ring. And one of the atoms من 6-member ring من 6 atoms اللي بالحلقة السداسية هو عبارة عن oxygen. So it's a cyclic ether. Okay, it's called a cyclic ether. شو هذا common name for that compound? I want you to check it out. And the last one that we will learn about from the naming of those cyclic ethers اللي هو ال 1,4-dioxane. This is the compound that's called 1,4-dioxane. It's a cyclic ether with 2 oxygens. مش 1 oxygen, 2 oxygens. And so this is called as 1,4-dioxane. So this compound is more polar than THF, for example. More polar لأنه فيه 2 oxygens, and more polar than this compound that you will learn the naming yourself about. More polar than that compound as well as a tetrahydrofuran. ليش؟ لأنه في عنا 2 oxygens in this structure over here. 1,4-dioxane زي ما حكينا هلا هدول كل الكومباوندز tetrahydrofuran هذا الكومباوند وال1,4-dioxane كل ال 3 compounds هدول they behave just like acyclic ethers زيهم زي الدايميثيل ايثر زي الدايإيثيل ايثر ما عليهم مش reactivity تبعتهم قليل كثير ما بتفاعلوا ما في تفاعلات نتعلمها عنهم الا just اللي هو الكليفج of those compounds اللي هو اذا حطينا عليهم HBr HI زي ما تعلمنا سابقا ممكن يتفاعلوا معهم ويتحطموا to alcohol and alkyl halide. But this is the only thing that you can do عليهم. But these compounds have more useful purposes. ممكن نستخدمهم because they have a polar moieties اللي هو الأكسجين and they have a non-polar اللي هو الكربون. These compounds are commonly used as solvents reactions. لأنه solvent of reaction you need to have that solvent to have some type of good water solubility. ممكن يذوب لنا البولار والنون بولار كومباوند في non polar and polar part. البولار اللي هو الاكسجين non polar اللي هو الكربون. But at the same time you want your solvent to be non-reactive. ما بدك السولفنت تبعك يروح يتفاعل مع compounds that will react with each other. Solvent just a way to dissolve your chemicals. It should not react with any other reactant or reagents موجودين جوا التفاعل تبعك. So these compounds have a perfect physical chemical properties for this اللي هم cyclic ethers ما عدا ال 3 member ring. أنا ما بحكي عن الإيبوكسايد هلا راح أحكي عنها. الإيبوكسايدز are very reactive. They are much more reactive than all of these 5-6 member ring cyclic ethers. So these compounds اللي هم 1,4-dioxane هذا الكومباوند اللي بالنص والتتراهيدروفيورين all these 3 compounds are mostly and mainly used for their ability for dissolving substances just as a solvent in reactions. That's the only thing that we use them for. طيب إذا حكينا عن هدول 3 compounds اللي هم عبارة عن cyclic ethers ما عدا ال 3 member ring اللي حكينا اللي هو الإيبوكسايد. خلينا نطلع على الإيبوكسايد ونرسم هذا السلايد فقط الإيبوكسايد structure. Let's draw an epoxide. This is a simple epoxide compound, simple epoxide structure. And that epoxide, as you can see, it's a 3 member ring. في 1, 2, and 3 over here. It doesn't matter. أنا numbering المفروض يكون من الأكسجين. So let me do it the correct way. 1, 2, 3. طيب هلا هاي الرينج الإيبوكسايد رينج as you can see is a 3 member ring. أنا بدي أشرح شو الفيزيكو كيميكال بروبرتيز لهاي الإيبوكسايد فراح أرسمها هون وراح أسأل سؤال briefly. And I would expect you to try to know the answer for that before I do anything. The oxygen over here, and let me use a different color. The oxygen over here, what is that hybridization of that oxygen? الأكسجين زي ما بنعرف عليها 2 lone pair of electrons ما بيهموني كثير ما راح أحكي فيهم وعليها هون كمان رابطين هاي الرابطة وهاي الرابطة over here وراح أمسح الدوائر اللي كتبتهم عشان ما نخربط بس موجود عليهم 4 يعني زي ما تحكي كأنه 4 things attached to it 2 lone pairs 2 bonds. So the hybridization of that oxygen is sp3 وحكينا كل الايثرز الاكسجين تبعتهم sp3 hybridization. طيب شو الانجل تبعت الاكسجين البونز تبعون هذول الاكسجين اللي مرتبطين حكينا it should be as we all know when it's sp3 oxygen it should be a tetrahedral the bonds should be in tetrahedral shape and so the angle of those bonds as we all know should be 109 or somewhere close to 109. ممتاز. طيب نيجي لهون لهاي الكربون over here. I want to ask the same question too. That carbon, what is that hybridization of the carbon over here? Simply to know بدك تطلع الكربون عليها كم رابطة؟ عليها 4 روابط. فعليا في هون 2 hydrogens we're not drawing them. We can draw them if you want to, if that makes things easier for you. So the carbon over here that I'm talking about should have an sp3 hybridization. That carbon over here should have an sp3 hybridization. ممتاز. طيب based on this, the carbon, the angles in the bond here of the carbon should be also 109.5. تمام should be 109.5. بينما لما نطلع على الستركشر هون هي فعليا مش 109. شو الزاوية هون؟ What is the angle over here? Can you tell me what is the angle? That angle over here? هذا مثلث الإيبوكسايد لأنه في 3 members or في 3 atoms attached. So the angle over here and this carbon between these two bonds between high bond وهاي البوند في الكربون is what? It's not really 109. It's less than that, and it's 60. The angle over here is 60. So instead of 109, we see basically 60. What does that mean? That mean إنه الأتوم هون الكربون sp3 مفروض يكون الروابط اللي عليها يكونوا 109 بس فعليا احنا ما بنشوف 109 بنشوف 60. شو تأثير هذا الحكي؟ تأثير هذا الحكي إنه two bonds over here they feel stressed out. يعني هم they are under so much pressure because it's a 3-member ring. These two atoms are pushing themselves. لأنه عشان نسكر الرينج ونعملها حلقة ثلاثية لازم يكونوا ب60 ما راح يكونوا ب109. Alright? So in that case that bond is, we call it under so much stress or under so much pressure. This cause what we call مصطلح معروف ب 3-member ring as ring strain. بنسميه as ring strain. شو ring strain؟ طبعا هاي R over here. الرينج strain انه الرينج itself الكربونز اللي موجودين بالرينج او الاتومز اللي موجودين بالرينجز مفروض الزوايا تكون 109 لانهم sp3 hybridized, بس we're pushing them, we're putting so much pressure on them to make them 60 instead of 109. This creates a huge energy in this ring. هاي الرينج فيها very high energy. ليش؟ لأنه هدول two bonds بدل ما يكونوا 109 اللي هو comfortable situation تبعهم، لأنه هاي الأتوم sp3 hybridized محطوطين بزاوية 60، فكأنه يعني ضاغطين عليهم، حاطين بريشر عليهم هدول التو انجل أو هدول الرابطين يقربوا على بعض لزاوية 60. شو معناته هذا الحكي؟ معناته هاي الرينج 3-member ring has a huge ring strain. شو يعني strain؟ يعني فيها كأنه tension عالي. شو يعني tension؟ يعني pressure، يعني فيها high energy. So it's very reactive. This epoxide rings أو these epoxide rings اللي مرسومين هون they're extremely reactive because of the ring strain. Because of the ring strain they're very reactive. These are very reactive compounds or very reactive functional groups. So epoxides, ethers, the only ethers that are reactive اللي هم 3-member ring، اللي هم 3-member ring زي epoxide هاي اللي بنحكي عنها. And these epoxides as we know شو سبب الهاي reactivity؟ إنه الزاوية هون اللي موجودة عندنا over here is 60 as we seen. So this is 60 instead of 109, which makes it very stressed out, very stressful situation لهاي الring. So instead of 109. So the only way to relieve this stress عشان نخلص من هاي الستريس وهاي المشكلة اللي هي ال 3-member ring اللي موجودة والروابط عم بتصير 60 بدل 109، انه بحالة وجود any nucleophile، شو ما كان النيوكليوفايل weak فعليا بيجي بيعمل اتاك على هاي الكربون over here nucleophilic attack. وليش على هاي الكربون؟ لانه طبعا كلنا بنعرف انه الكربون لما تكون bonded مع الاكسجين راح يكون عليها partial negative. نفس الشيء هاي الكربون عليها partial negative. So either or one of these two carbons اللي موجودين سواء كانت هاي الكربون او هاي الكربون عليهم partial I'm sorry طيب let me I mixed it up 1 second. okay. طيب خلينا نرسم epoxide. حكينا هذول الكربون، عفوا الكربون عليهم partial positive وليس partial negative. Again so it's a partial positive على هذول الكربونز لأن الأكسجين is more electronegative atom. okay, so they have a partial positive على two carbons والnucleophile عليه negative or partial negative. So these carbons, any of those two carbons over here, they have a partial positive. And حكينا لأنهم جزء من 3-member ring, they're highly stressed out. فيهم very stressed, very high energy. So they're very ready to react with any nucleophile. And so the nucleophile can do a nucleophilic attack, as we can see على one of these two carbons. And the result of that, if you want to make a new bond مع هاي الكربون, you have to break a bond, and that bond. And so when this nucleophilic attack happens على واحدة من هاي الكربون راح نصير رابطة جديدة between this carbon over here and between this nucleophile, and so that you're gonna break a bond. البوند راح ترجع إلكتروناتها للأكسجين. راح ارسمها also in another way just to make sure and you understood that what I'm talking about. So if we have an epoxide over here and that epoxide as we all know مرة تانية بس عشان ارجع اكد انه واضحة للجميع ان partial positive على هذول two carbons and that oxygen عليها partial negative, and so these are carbons highly strained عليهم very high energy because they are in 60 الزاوية تبعتهم 60 بينما المفروض يكونوا 109. And so the nucleophile any nucleophile راح يعمل لنا attack over here, راح يجي يعمل لنا attack على هاي الكربون nucleophilic attack عشان يكون لنا رابطة راح عشان يفتح الرينج وبصير الكترونات الاكسجين بترجع لها. شو راح ينتج عندنا البرودكت that we produce? The product that we produce is over here. I'm gonna draw it in the next slide. So let me draw this again. If we have this epoxide مثلا وضفنا عليها any nucleophile or a nucleophile react with that epoxide, and this will do a nucleophilic attack on that carbon. The electrons goes back to oxygen, so the produced product will be an open epoxide. يعني تحولت من closed epoxide to, وهي الرابطة جديدة راح اكتبها بلون فقط مختلف to make things easier, and this is our nucleophile. So the epoxide now is open, بطلت epoxide anymore. For opening of those epoxide will produce this molecule. This molecule basically is not an ether anymore, is an alkoxide. This is an alkoxide, and that alkoxide, if we add a proton عليه H3O plus at the end of the reaction, will produce an alcohol. Okay, so reaction of epoxide typically produce an alcohol. ليش؟ لأنه راح يطلع لنا هذا الكومباوند نفسه اللي رسمته سابقا. As we've seen, this is the same compound. Okay, so this is simply what the epoxides are. اللي بدي تعرف عن epoxides, they're very reactive. So they're very special type of ether. They're not the same as the previous ether we have seen earlier, and they react very quickly with any nucleophile. السبب اللي هو الرينج سترين. شو يعني رينج سترين؟ رينج سترين هي فعليا انه الزوايا بالرينج هون 60 بينما because the atoms in these three member ring الاتومز اللي موجوده الكربونز والاكسجين sp3 should be instead of 60 بزاويه المثلث لازم يكونوا 109 فهم بالسيتويشن مش كثير مريح. ففعليا شو بصير انه these will be under very high energy and stress to end up breaking themselves and leave يعني فعليا, and this is why they are very reactive. And so these angles are 60 over here, 60 and 60 بينما المفروض يكونوا 109. فأني nucleophile بيعمل اتاك على هدول الكربونز over here will open up the ring, راح يعملها opening يكسرها يفتحها الرينج وينتج عندنا linear compound as we have seen over here. So that's why those epoxides are very reactive. Alright, the reason for the reactivity ring strain. شو يعني ring strain؟ في البريشر اللي بدل ما يكونوا 109 لأنهم sp3 hybridized carbons or oxygens they are 60 الزوايا موجودين. This means higher energy or higher strain and means more reactivity. Okay. طيب إذا حكينا عن شوي عن epoxides وحكينا إنهم عبارة عن cyclic ether, special type of cyclic ether that they are very reactive. خلينا نحكي شوي عن naming of these compounds. هلا خلينا to start with a very simple naming for this specific compound, and it's just this is the simplest epoxide that you can find. راح أعلمكم فقط اللي بيهمكم أو اللي راح نستخدمه كثير اللي هو الأيوباك system naming for the epoxides. How do we name them? Epoxides get always the epoxy prefix before the name when you want to name any epoxides by IUPAC system. So we start usually as we start with any other structure or functional groups ناخذ the longest hydrocarbon chain, and this is the function. This is the longest hydrocarbon chain over here. It's just 2 carbons. We need to number them, and this is the longest hydrocarbon. راح نرقمها as 1, 2. So in this compound we will name it basically as 1, 2 هنحط كلمة epoxy لأنها تعبر عن وجود epoxide ring, and then it's 2 carbons only, so 1, 2 epoxy ethane. This is the name of that molecule, 1, 2 epoxy ethane. واضح? So it's very simple, very straightforward. Okay, خلينا ناخذ structure that's even more complicated. Let's do another one. For example, this type of epoxide. maybe do this one, add the methyl over here and another methyl and an extra methyl as well over here. Okay. طيب هلا هذا الكومباوند again we have to look for the longest hydrocarbon chain. You can see by eye this is the longest hydrocarbon chain over here. So this is our longest hydrocarbon chain. We need to number that. We can start either from the left side or the right side. What I want you to know, and if we start from the left side, let me use the pointer to show. If we start from the left side, المثل هاي راح تيجي على رقم 2. بينما if we start from the right side, المثل هاي راح تيجي على رقم 3. So we should start from the one that gives the methyl the lower number. الإيبوكسايد ما راح تتأثر، راح تظل 2 3 أو 2 3 من الجهتين. So we should do from the left side only. So the numbering will be like this, and it's going to be 1. Let me use a different color. This is not the perfect color to do yellow. Let me use the black color, and this is going to be carbon number 1 over here. This is carbon number 2. Oops. So yeah, this is carbon number 2. Okay. Delete this. So this is carbon number 2 over here, and this is carbon number 3. This is carbon number 4. So what do we have? We have a 2,3 epoxy group. وعندنا carbon number 2 we have a methyl. So this structure will be named like this: 2,3 dash epoxy. طيب حطينا الايبوكسي اول لانه الاي بتيجي قبل الام، بعدين راح نحكي 2 methyl dash بعد الميثيل هو راح يجي اللي هي longest hydrocarbon chain butane. So this is one name. Okay, so it's named as 2,3 epoxy 2-methyl butane. This is the name of that compound. Okay, واضحة؟ طيب these are very simple compounds. راح نحكي عنهم وراح نحكي عن كمان if we want to do, for example, let's draw a cyclohexane structure. Let's do this structure over here. So if that's cyclohexane, we have epoxide ring عليه. Okay, so we have an epoxide ring. Let me draw it in the appropriate way. This is an epoxide. So how do we name this compound? This compound is named as 1,2 epoxy cyclo. Let me draw this again. Cyclohexane. Okay, it's named as 1,2 epoxy cyclohexane. ليش؟ لأنه هذول carbon number 1 2, so it's 1,2 epoxy cyclohexane. So كيف بنسمي الإيبوكسايدز؟ Just simply by adding the prefix epoxy and numbering it, giving it the correct number. Okay. Alright. هيك بنكون خلصنا هاي المحاضرة. المحاضرة الجاية راح نحكي عن شوية تفاعلات، كيف بنحضر الإيبوكسايد وكيف بنفاعل الإيبوكسايد عشان ناخذ منها other functional groups زي الكحول والother type of functional groups. يعطيكم العافية.